Looking at a negative feedback configuration with an op-amp circuit. Again, we will assume that there is no saturation here. So if we have two nodes that are identified and the question is asking for the voltage values here, VA and VB. We also need to calculate VO, and we need to calculate the feedback current IF. So the first thing that we would like to do is try to calculate what the voltage is at the positive input terminal. If there is no saturation, whatever is here, which is V plus, has to be equal to the negative input terminal. So this value here is also going to be VB. So we need to write the expressions, node voltage expressions, to calculate what these voltages are. So for this one, for this node, we can write the currents leaving this node as these three currents. And then for this node, we can write for the second one, we can write the currents leaving VB. And then for the negative input terminal, again, we can write the node voltage expressions. Let's start with this one. We have VA minus 0 divided by 2 kilo ohms plus VA minus 2 volts divided by 2 kilo ohms plus, now in order to calculate this current here, I need to know what this voltage is, which is VA plus 2 volts. So it is VA plus 2 volts minus VB divided by 2 kilo ohms equals to 0. So this is one equation that we have. The denominators are the same, so they can be cancelled out. From this equation, we get 3VA minus VB equals, this is minus 2 plus 2 equals to 0. That's one equation that we have. We can write another equation here on the VB node that would say VB minus VA over 1 kilo ohm plus VB minus 2 volts over 1 kilo ohm equals to 0. Again, the denominators are the same. What we end up having here is 2 VB minus VA equals to 2 volts. From here, we have two equations and two unknowns. We need to calculate VA and VB. So if you multiply this equation with 3 and sum the two equations, we end up getting rid of the VA component. So we have minus VB plus 6 VB equals to 6 volts. That means that VB equals to 6 volts over 5. If we know what VB is, we can calculate VA, because we can use any one of these expressions. From the first equation, what we have is 3VA equals to VB, which is equal to 6 volts over 5. This means VA equals to 2 volts over 5. We have calculated VA and VB. Now, if you know VA, you know what this voltage is here. This is 2 volts plus VA, which is 2 volts over 5 plus 2 volts. That makes 12 over 5 volts. Since we know VB, we can calculate the feedback current, which runs in this direction, IF. IF equals to VB minus VA plus 2 volts over 2 kilo ohms, which is equal to 6 volts over 5 minus 12 volts over 5 divided by 2 kilo ohms. That gets us minus 6 volts divided by 10 kilo ohms. So feedback current equals to minus 0.6 milliamps. If we know the feedback current, then we can also calculate the VO, because VO minus VB equals to IF times the feedback resistance value, which is 1 kilo ohm. So VO equals to minus 0.6 milliamps times 1 kilo ohm plus VB value, which is 6 volts over 5. So what we get here is 6 over 5 is the same as 12 over 10. So this is 1.2 volts, and this is minus 0.6 volts. So VO equals to 0.6 volts.